Good morning, girls. Today we are going to see about digital image processing. So, from the name itself, you can understand the digital images are to be processed. So, what is image? So, image is nothing but a photo that is taken from any one of the devices. So, here the digital image processing means we are taking a digital form of the images. So, if you are taking in the olden days, we have a films. From the films, we are take the images. But now we are having the digital cameras. So, from the digital cameras, we are taking the images. So there is one word that is one picture is worth than more than 10,000 of words. So what importance a picture has? So a picture will talk. A picture will tells us more things when we see the picture. So that picture we are going to process. So first one we want to know what is digital image processing. So what is digital image processing? It is a representation of the two-dimensional images. So what is two-dimensional images? So it has x-axis and y-axis. So the image is to be displayed in x and y axis. So it has a finite set of digital values. That values are called as the picture elements, or we call it as a pixels. So in this image you can see that how the picture is to be displayed in a plane. So it has a x coordinate as well as a y coordinates. And this picture elements values typically represents the gray levels of the images, or the colors of the images, or the height, or the opacity, etc. So in that we want to remember that digitalization implies that the digital images is an approximate of the real scene. So this digital images give the good accuracy of the images. So the accurate of that images that is to be seen in the digital image photos. So these common image formats are said if you are taking one sample per point, then it is a black and white images that are called as the grayscale images, and in that some samples per point, that red, green and blue, that is called as the RGB color images. So it has a three combinations of colors, red color, green color as well as the blue color, and four samples per point. It means that it has the red, green, blue and the alpha opacity of images. So here there are three pictures. You can see the difference of these three pictures. In the first picture, it has the black and white images. So we call it as a grayscale images. It has only the black color and as well as the white colors. And if you are taking the second image, it has the red, green and the blue combinations. And the fourth image, it has a red, green, blue and the alpha colors. That's alpha opacity of the colors. So according to this opacity, the display of the image will be differ. So what is digital image processing? The digital image processing, it focuses on the two major tasks. We are improvement of the pictorial information for human interpretations and processing of image data for storage, transmissions and representation for autonomous machine perceptions. So some arguments about where image processing ends and the fields such as the image analysis and the computer vision starts. The continuum from image processing to the computer vision can be broken up into the low, mid and the high level process. So that is low level process, we are giving the input as an image and we get the output as an image only. So examples, if you are giving a noisy image, that noise are to be removed and we get the good quality of the image, and the images are to be sharpened. Then we are giving the noisy image, it will sharpen the edges and it gives a good quality of the image. So the input and the output both are to be images you are getting. That is the low level of processing of the image. Next, mid level of processing of the image. So here we are giving the input as an image and we get the output as the attributes. So the object recognition or segmentation, we get the attributes from the image. From the image we are collecting the attributes. So we get that the size of the, if you are, for example, if you are taking a tumor image, then we can tell that the size of the tumor, how much it will be spread and what is the width, what is the height, what is the dimension, and that are the attributes that will be get from that image. So that is the output we get from that image. Then high level processing. The high level processing, we are giving these attributes. From the attributes what we will understand. So if you are taking this same tumor image, from the attributes we are classifying whether it is a tumored or it is non-tumor. So we are come to an understanding that from this attribute. So this is the high level of processing. So what understanding we are getting from that image. So that is the high level of processing of the image. Now we are going to see about the history of the digital image processing. So in early 1920s itself, this digital image processing are to be used in the newspaper industries. So the newspaper industry is the first digital image processing that we are used. So it is the first application of the digital image processing, and the Badland cable picture transmission service. So that is the first image transmission services that to be use the digital image process. So the images were transferred by the submarine cables. So they are using some cables to transmit the images from the London to New York. These pictures were coded for the cable transfers and reconstructed at the receiving end on a telegraph printer. So this is a yearly digital image processing. This is the photo of the picture of that the yearly digital image processing. You can see the how clarity that image is. So it has a very low clarity of the image. You can see. Next, in the mid of the 1920s, there is an improvement to the Badland system, result in the high quality images. So when you compare to the previous images, now we can use some more improvement in the digital image processing. There's a new reproduction process based on the photographic techniques, and it increases the number of the tones in reproducing the images. So they increases the tones. So how the image, how to improve the quality of the image, they improve that tones. So they take in the 50 different tones to improve this digital images. And in 1970s, the digital image processing began to be used in the medical applications. That is in 1979, the Sir Godfrey Yen and Hounsfield and Professor Alan M. Cormack shared the Nobel Prize in the medicines for invention of the tomography, the technology behind the computerized axial tomograph, that is CAT scans. So here the image processing is to be used in the medical side to take some scans. So this is a CAT type of scans, that is a tomography images. So when you compare with the previous images, you can understand how what quality of the images. So before that, you want to see in the 1960s, they take some images from that sky, that is that space. So how this quality of the image, you can see that is the improvement in this computer technology and the onset of the space race lead to the surge of the work in the digital image processing. In 1964, the computer used to improve the quality of the images of the moon taken by the Ranger 7 probe. Such technique were used in other space missions including the Apollo landing. So when you compare this medical images, this space image are somewhat less in quality, and if you take this previous images in the 1920 images, it was very low in quality. When that in 1920s, in the early 1920s, it is very less quality. So when you compare this early 1920s with that images that taken in that 1970s, you can see the difference, how the technology is to be improved in the digital image processing. Next, this is a very important thing, that is the stages in the digital image processing. So first one, the image is acquisition. Image acquisition means from any one of the device we are acquire the image, and after acquiring the image, then we are enhancing the image, that is the image enhancement. Next we are restoring the image, and we are doing some morphological process, and we are segment that image, and the object recognition, and the representation and description. So the color image processing and the image compression are to be done in the images. So an image is to be acquired, then from that acquired image, the image want to be enhanced by using some of the algorithms. There are a lot of algorithms how to enhance the quality of the image, and how to restore that image, and how we want to do some morphological process inside that image. And for segmentation also we are having a lot of algorithms, and for object recognitions also we are have a lot of algorithms. So nowadays we are using that ML, that is machine learning concepts, as well as the deep learning concepts for segmentation, as well as the object recognition. So the object recognition means we are classifying that objects as a we are classifying the objects. that if you are taking a data set of a dog and a cat, then we are classify whether it is a cat or a dog. Or if you are taking a medical images, we can classify it as whether it is a tumor or a non-tumor, and we can classify that human also, whether it is a woman or it is a man. Likewise, we can categorize all the things. So for this we are using a lot of deep learning algorithms as well as the machine learning algorithms, and nowadays there are a lot of technological concepts. When if we are taking this deep learning, there is a advanced of deep learning as a deep neural network, and we can use as a transfer learning concepts. So there are a lot of things nowadays we are used. So but if that the important thing is that the image acquisition, and we are enhancing that image. This is a very important thing. So when you are acquiring image, how much we are enhancing the image, from that we can get that good quality of the image, and it is easy for you to classify the image and to improve the accuracy of the image also. So this is the enhancement of the image. So this image is to be enhanced. So how the accurate images, so it is somewhat with a low quality. Then if you are using some enhancement concepts like sharpening the image, or we are removing the noise, like there are a lot of algorithms, noise removing algorithms, and to enhance the image we can use as a sharpening algorithms, smoothing algorithms. There are a lot of algorithms that will be used to enhance the image. And this is image restoring. How we restore image, we can see that quality of the image, there is a very lot improvement in the quality of the image, and we can do that morphological operations inside that image, and you can segment that image, segmenting the image, and we can classifying the image by recognizing that image. So this is representation, how we are representing the image in the graphical mode. And this is the image compression, we are compressing the images. And this is color image processing. So this is the color image processing. We can easily identify the presence of the tumor in that image and how much it is to be spread. Okay, thank you.